Hi, my name is Sarah, and I'm joined by my colleagues Yasin and Terrence. We're thrilled to be here today. We appreciate the time you have invested in talking to us, sharing your experiences, and providing feedback. Privacy continues to be a focus for us. It is a core principle we embed in every product and strategy decision. As you have experienced over the last several years, Android has been innovating and launching new privacy features with each release of the operating system. And this year is no different. For this session, we will provide you with an overview of new privacy changes, and we will share approaches to developing privacy user-centric apps. We're often asked, what does it mean to build privacy-centric apps? On Android, we have a set of principles that guide our design, and we believe it can also help guide yours. These are, first, paying attention to data being requested and respecting user choice. Second, choosing privacy-centric alternatives. And third, minimizing access to data. Let's go into more detail. Data transparency and control are central to Android's privacy principles. Android 12 introduced a number of new features that bring more transparency to the data accessed by apps, such as privacy dashboard, privacy safety labels, and microphone and camera indicators. Users want to know about what apps are doing with their data. In the privacy dashboard, over 40% are engaging with the details of app accesses. The feedback and user engagement has inspired us to add more transparency to the privacy dashboard. Android 13 will extend the timeline from 24 hours to 7 days. This allows users greater visibility to every access an app makes to microphone, camera, and location. We ask developers to be intentional with their access and only access data when a feature is enabled by the user. To help developers untangle mapping of your code and dangerous permission access, Android provides auditing APIs. The audit APIs make it possible for you to track which part of your code is accessing private data and to track and control data access by third-party SDKs. The API instructs the system to invoke an app-specified callback each time the app accesses sensitive data. The callback provides information about the type of data being accessed and lets you record the stack traces and timing of the access. Please make sure to review the APIs and use them to understand your data access. At times when your app needs access to data gated by runtime permissions, we encourage you to provide users with clear rationale for the data access. Recent studies suggest that unexpected permission and permissions without rationale have higher deny rates. The rationale will help users understand the access and ensure they're comfortable granting permission. This guidance also applies to the new notification permission introduced in Android. Going forward, all new apps, irrespective of Target SDK, will require permission before they can send notifications. Apps targeting Android 13 will be able to declare post notifications in their manifest and request a permission in context with appropriate justification as to why the app needs to send notifications. For apps targeting SDK 32 and lower, the system will automatically prompt the user for the permission when the user launches your app the first time. We encourage all developers to review these changes carefully and prepare your app to request the permission in context with rationale. Your app can also provide a rationale for users to help them understand why you need access to location, camera, and microphone information. The rationale can appear on the Privacy Dashboard UI, your app's permission screen, or both. Android 13 will make it easier for users to manage the foreground service notifications. We often hear from users that foreground services can clutter their notification shade, but we also believe that it's important for users to know when apps are running foreground service. To help improve the experience, going forward, users can dismiss foreground service notifications, but always be able to find them in the new Active Apps UI. All foreground services will always appear here with an option for users to stop the foreground service from running. Please make sure you are being thoughtful about what foreground services are required and that it's obvious to users why your app needs to run a foreground service. I'll now hand it over to Yassine, who will tell you more about privacy-centric APIs.
Thanks, Sarah. In addition to privacy and control, Android is focused on providing more specific alternatives to permissions which offer more transparency and flexibility to users. Over the past few releases, you likely have noticed that Android has made some changes to the ways apps access users' files and media. This year, we're adding more solutions to help you build your app with user privacy in mind. Before we dive into them, let me give you a refresh on the state of storage on Android with some use case illustrations. For data that's intended to be private to your app, you have two choices of where to put files. Let's say your app saves some information in a database or a config file that you want to keep private. You should save these files into your app's internal folder. The internal folder is located within the device primary storage volume, which guarantees faster access than on an external one. To do so, add the file within the folder returned by context.getFilesDir method. If you need to save bigger files, your app's internal storage should still be favored, but some devices have limited space on the primary storage volume. You can check for available space in the volume containing the internal storage folder by calling the file.getUsableSpace method. If your app's internal folder hasn't enough space, you should rely on your app's primary external folder. On some devices, it's located on the SD card. To do so, add the file within the environment.getExternalFilesDir file tree. On devices running Android 11 and above, these files can't be read by other apps, but they can be visible to apps on older devices. So don't keep anything extremely private here. Now, what if your app wants to create content that is intended to be shared? Maybe your app takes funny pictures that the user wants to access from their favorite gallery app. In this case, you should save files in a shared folder. These files will remain even if your app isn't installed. Android automatically creates several shared folders where apps can add specific types of files such as pictures, movies, music, podcasts, etc. Adding files to the appropriate shared folder doesn't require any permission after Android 10. Let's get the images folder by calling environment.getExternalStorage public directory with environment.directoryPictures as a parameter and add the file there. Files need to be put in the appropriate shared folder. Pictures go in Pictures, MP3 in Musics, PDF in Documents, etc. Once we save our image to the file location, we need to scan the file path to make the file visible to other apps. Now imagine your app is a budget tracker for professionals that need to keep track of their receipts. Accepted attachments could be PDF files, for example. These kind of files cannot be read using a permission. Instead, we have the Storage Access Framework API. Because the UI where the user chooses files is controlled by the system, this API does not require permission, making it maintenance-free for developers. To open the document picker, invoke an intent that contains the action OpenDocument action, as well as the set of MIME types that your app accepts. Instead of writing the whole logic for intent interaction, let's use the OpenDocument activity result contract inside Jetpack ActivityX, which will handle all of that for us. When launched, the intent will show a file navigator screen to the user so they can select the right file. Once the file has been selected, our callback will receive a URI that we can read with contentresolver.openInputStream. To help bring more transparency into the type of files that apps have access to, we're introducing more granular permissions where accessing shared media files on apps that target Android 13. Read external storage and write external storage are no longer supported for apps targeting API 33+. Instead, apps can request 3 more specific permissions with their names matching their respective file scopes. Read Media Images for image and photos, Read Media Video for videos, and Read Media Audio for audio files. Photos and videos are in the same permission group, so the user will only see one dialog if you request both permissions, but audio file access is now decoupled. If your app was already granted Read External Storage, users won't need to reapprove either of these permissions after you upgrade. Make sure you set a max SDK version to 32 on deprecated storage permissions when targeting Android 13. But will it not be better to let the users decide which specific images and videos they want your app to use without having to request any permissions? Say no more. We're introducing a privacy-forward and maintenance-free picker for images and video. Apps can now just launch an intent on Android 13, and you can even limit the number of selectable items as well. The photo picker will be released using Google Play system updates. This means it will be available in the upcoming weeks on Android 11 and 12 devices, and we can continue to improve it over time without waiting for OS updates. In an upcoming update, cloud media providers like Google Photos will also be supported. The photo picker will seamlessly include backed up photos and videos as well as custom albums you have created. Now let's look at this code snippet to launch the photo picker. In less than 5 lines of code, we have a photo picker well integrated into our app UX, which doesn't require any permission, includes cloud content, and relies on Action Open Document on older devices, making it much easier to select photos and videos on all devices from Android, KitKat, and above. Well, that was quite a showcase. We've seen how to add files in our app's internal storage and the device shared storage, use a privacy-centric file picker, and access the user's media files. You can find all of these code snippets within our storage samples on GitHub at this address. Now I'll hand it over to my colleague Terence, who will tell you more about how to limit your app's access to private user data.
Thanks, Yassine. Now let's go over the third pillar of building privacy-focused apps, limiting your app's data access. Users have become increasingly sensitive to apps accessing their private data, and they have consistently told us that they want an OS that protects their privacy and treats their data with care. Android has responded by adding more transparency to the OS, with features like camera and mic indicators and the privacy dashboard that we've discussed earlier. Keeping these new privacy features in mind, we ask that you design your apps to reduce the burden on users by only accessing user data when it's critical for your app to work. Let's go over a few ideas on how you can reduce data access in your app. We can begin with location accuracy, as location is one of the most sensitive user permissions. In Android 12, we've added additional controls for location. Users now have a clear choice to provide less accurate location data to apps by selecting approximate instead of precise location when apps request access. We encourage all developers whose apps need location access to review your use case and only request access coarse location unless the current feature requires the user's precise location. For example, let's imagine a group event app that at first only needs the user's approximate location to suggest activities for them in the area. After the user selects an activity, the app will then need their precise location to give detailed turn-by-turn instructions to meet other participants. When users first launch a group event app, it should only request access course location in order to give group activity recommendations near the user. After the user selects an activity and clicks on the feature that helps them find other participants, the app can now request to upgrade to access find location. If the user denies the upgrade request, other features in the app should still work. To summarize, even if you decide that your app needs precise location access to unblock certain features, it's important that you start with approximate access and progressively request precise location as and when your features need it. Also, always be prepared for the user to only grant approximate location access to your app. your app should still continue to work. Now let's explore a code snippet of requesting course location access and handling the results. This provides the app with an estimate of the user's location within 3 square kilometers, which should be enough for many features, including the activity suggestion part of our imaginary group event app. If later the user clicks on a feature that needs find, such as navigation support to find other participants in our previous example, then the app can present the user with an upgrade dialog by requesting access find location. As always, make sure users understand your location use case before requesting access, and also check to see if you should present a rationale by calling the should show request permission rationale API before requesting all runtime permissions. In addition to direct location access, apps previously had to request and obtain location permission in order to access many Bluetooth and Wi-Fi APIs. The APIs also cause permission checks when they're called, which means users will see that the app has accessed their location on the privacy dashboard. However, this leads to user confusion and dissatisfaction, as often the connection between location and the intended use case for some of these APIs aren't really clear. One example of this is when companion apps for devices such as watches or headphones request a user's location just to scan for Bluetooth devices. Android 12 introduced a nearby devices permission group for common APIs used in Bluetooth. The nearby permission will now include commonly used Wi-Fi APIs for scanning and pairing with nearby devices. Privacy-preserving technical changes made to commonly used Wi-Fi APIs will allow developers to access them without requiring access find location. This allows developers to more easily justify their Bluetooth and Wi-Fi access and reduce user confusion. Now is the time to look through your code that handles Bluetooth and Wi-Fi connectivity and see if you're deriving any user location from those APIs. If not, make sure you add the never for location flag to the particular Bluetooth or Wi-Fi permission, and those API calls will no longer trigger location access. Here are the Bluetooth and Wi-Fi permissions that are eligible for the never for location flag. For Bluetooth, we have Bluetooth Scan, Bluetooth Advertise, and Bluetooth Connect. For Wi-Fi, it's the new Nearby Wi-Fi Devices permission. And lastly, for ultra-wideband, we've got the UWB ranging permission. Now let's go over a manifest snippet for an app that needs to scan for Bluetooth devices and also start local Wi-Fi hotspots. This app doesn't derive any location information from those APIs. You can see the Bluetooth Scan and Nearby Wi-Fi Devices permissions are listed here in a manifest, along with the never for location flag included for both permissions. In addition to location, the Privacy Dashboard and Application Info page also present a clear view of apps with access to other runtime permissions, such as camera, microphone, and nearby devices. This additional visibility presents a good motivator for downgrading your app's unused permissions, which could be left over as a result of a deprecated feature or because your app was pre-granted permissions from being bundled with the device. When targeting Android 13 or API 33+, your app will be able to call these APIs to downgrade permissions. To downgrade a single permission, you can call the Revoke Self Permission on Kill API and provide it with the name of the permission that you would like to downgrade. Similarly, you can downgrade a group of permissions using the same Revoke Self Permissions on Kill API. Besides permissions, clipboard content can also be quite sensitive for users. Users frequently copy emails, addresses, and even passwords, and all of that data is stored in the clipboard. From Android 12 onwards, users will be notified every time an app reads clipboard data that originated from a different app. As a reminder, calling getPrimaryClip may trigger this toast notification, depending on where the clipboard data originated from. You can minimize unnecessary clipboard access by first calling getPrimaryClipDescription to see if it's the right type of data you need before calling getPrimaryClip. To further protect the potentially sensitive data in users' clipboards, starting in Android 13, the system will automatically wipe the clipboard content about 1 hour after it has been last accessed by the user. Remember, the most important recommended best practice is to only access the clipboard when the user understands why. Now, let's take a moment to summarize everything that we've discussed today. Here are the main takeaways for developers. Protecting users' privacy is a top priority for Android and our ecosystem. We're focused on bringing features and tools that help developers build private and user-centric apps. This means paying attention to data being requested and respecting user choice, choosing privacy-centric alternatives whenever you can, and minimizing access to data. We really appreciate your time today. Please make sure to check out our other amazing I/O Talks. Thank you so much.